Okay, good morning. So this Monday we're going to have the cell share. Alright, so cell share including the ideal cell and actual cell. And in fact, we will have the Haskell to have the further discussion later. And of course, if we want to have the further simplification, then we can have the square. Okay. Or maybe sometimes we want to have the triangle to serve as a cell share for the cell. That's okay as well. And based on the possible cells, cell share, then we can have the list for the area and the boundary, and we can have some other calculation. So right now, I simply ask some of you to check. Can you have the area for square cell hexagon and stellar cell and triangular cell? So good one. Check this quickly, right? It's correct, all right? And good two. You need to check this, is it correct? And good three. It's easy, right? And good four, triangular. So 2 and 4, checking hexagon and triangular here. It says if we have R. And same if we have R here. So, is it correct to have the cell area? Actually, if we memorize, the formula, it's true. This formula for a triangular with the equal length. And how about this? Good four. So actually we have R. And here is R as well, So something like we can have one piece. If we have one piece, so far it should be 1, 2, 3, 4, 5, 6. Alright, so we have 6 pieces. If 6 pieces multiply 6 here. So is it true? Alright, so about area we can have these. You can further check boundary. Alright, boundary means the length of the boundary. So length of the boundary for triangular, correct, and correct. And the hexagon is correct. And the square is correct, right? And this is a ratio, so you can find the ratio. And channel over the area. So channel over area, can you have it? Right, for square. We have the given channel n over the area. Likewise over the area, so this one easy, right? And then you can have, for example, we have the increase factor k, so multiply k only. Later we want to know why you can have the increase factor k. But right now, we just don't know if we can increase the previous value by k, so multiply k. Or maybe reduce, so we can have the corresponding m squared. So for the final 2 columns, actually just ask you to have the multiplication k, multiplication m squared. Alright, that's it. So the table I think is easy to understand, right? So let me continue. And in fact, we will follow the results for the hexagon later, not for all the possible shares. And right now, I think it's easy to know if we focus signal strength. And right now we express the signal strength in dB. So that's why we have a minus 60, minus 70, 80, 90, and 20. And 100. What I want to show is if we have the signal strength, in fact, we want to know. Alright, so if we have cell I and cell J, in fact, the mobile station will move. If we have the signal strength from cell J higher than cell I, for example, here we have a line here. And then we need to switch from cell I to cell J. Then we can have a possible decision for the handoff. So we will have a handoff later. But that is an ideal cell share. And how about the real cell share? Perhaps if we still have the contour, minus 60, 70, and actually it is not a regular line. And right now maybe irregular line to have, maybe not line, irregular partition, so that we will have the same signal strength from cell I or from cell J, right? So we have the contours, and the contours actually let us have the same signal strength. So first of all, contours, and I think right now you know where we have the contour, but later we will definitely have some meaning using the keywords or key terms. Actually, we will emphasize contour, cell type, and Taiwan. Here, if you want to check, we have the keyword key term for you. And let me check for our name is here. Right? Alright, maybe I need to refresh it, so I need to start from the first page to the current one. And the second one, I think checking the way to explain Taiwan. I think it's easy to know this. And Taiwan, actually, you can check this. So, idea will have the circle to represent the cell share. And so that we can have the boundary, something like this boundary. Either we have a circle to have the boundary. But for try to have the tiles using cell. So actually we don't want to have the overlap area. If we don't want to have the overlap area, then hexagon will be a suitable one to describe the coverage of the cell. Even if we talk about the signal strength, we don't want to use hexagon. Instead, we want to use a circle. But later, we want to use the non-overlap area. So we will have the hexagon to serve as a cell share. If we have a cell share, previously we have a car moving from Cincinnati and towards Washington, D.C. So we will have a different cell to serve the current mobile station. And here we will have a handle, and handle. So many kinds of handle. Therefore, same. We want to check receive power. If here we have original base station and the mobile station move out to maybe towards a different base station. So for the current one, actually we have the receive power decay, and the other one increase. So we will have the decay power and increase power. Likewise, we will reach the point x5. And x5 actually we have the equal power. So we just use x5 to serve as a point to trigger the handoff. If yes, then we will have a ping-pong effect because the point is sensitive. Oh, okay, so if we move to this one, then choose J. And how about get back to I? So here we will have the sensitive label. We don't want to do that, so we will have the point here denoted by STH. So STH means we have a threshold greater than the previous label, maybe beyond a certain threshold, and then we think this is a point to trigger the handle. And then we will have hysteresis way to have the handle. So the 2 points here, it will be the possible option. Option 1, even we have the ping-pong effect. Option 2, we can avoid ping-pong effect possibly if we have the threshold higher than the previous power of the base station. Alright, you see? Actually, we choose this one. Alright, and then we will have the handoff to base station J. And in fact, we have some description by mention to you already. Well, here we try to repeat again. Actually, we should have the cell share. In fact, if we have a hospital, we don't want to have the overlap area. But right now, it seems to be okay. We don't have the rotation property, so that we will have the non-overlap area. So right now, even we have the overlap area, it doesn't matter because we have the equal strength here. Alright. But if we have a cell, okay, this one can be covered by this, and this one can be covered by that as well. But why we try to have this way? Oh, we have a bit more area because we try to have the actual area to indicate. Okay, it's possible to have the more actual power, and then we will switch to base station J. So if we intend to use the current to cell, something like we try to emphasize, even we have an area, but we still try to have a bit more area to tolerate connect to base station J rather than base station I rather than base station J. So in fact we try to have the area, but here we try to have no. Actually, we have the threshold, so we can have more time to stay in base station J, but still connect to base station I. Alright, so this is how to avoid some effect called ping-pong effect. So here we have the region. Maybe not the current region, perhaps we have a larger region. Within the larger region, something like we have the buffer. The buffer here still maintain the connection with the original base station. If we move from original base station I to base station J, or likewise move from base station J to the current base station I, we will have a buffer within the buffer area. Then we still connect to the original base station positive. But we have the rectangle node based on the power, and the power try to have some possible buffer area. And so that within their buffer area, don't to switch to the new base station immediately. Alright, that's it. So, because of ping-pong effect, we don't want to use X5. Instead, we want to use XTH. And so that point will be the beta point to trigger handle. Alright, that's it. So, think about this and allow you to have 2 minutes to discuss with your neighbors and try to get closer. Okay, go and check it. So maybe for group 2, how to have maybe like group 3, right? Group 3. And group 3 actually, okay, that's fine. So like the way out for group 3, some of you try to have the seat rearrangement. Maybe, how about me? You go there and try to rotate the seats. That way. Maybe first Jen. Yeah, that's correct. And to try to rotate and so let me try to call your name again. William, Gabriela, right? Okay. And J, me, and Jane. And how about your name? Sham, Alex, Sue, Shirley, Thomas, and Gilles. So maybe Jane and me try to have a slight seat rearrangement like that. And Sean maybe in the middle. Yeah. Okay. So about this, maybe previously I don't set time, but after now it's okay. I mentioned one point, ping pong effect, right? Ping pong effect. So try to avoid ping pong effect. We don't want to use the point outside to trigger handle. That's it. If so, before I go, maybe they need a chair. Any questions? Up now? No, right? So if no, let's check this. Later, it's just an exercise. The exercise says, oh, okay, we have the considered area rectangle, and assume N1 is the number of mobile stations per unit length. A unit length here, and per unit length here. We have the mobile station per unit length in horizontal direction and in vertical direction. And right now we want to determine the handle, the way to have the handle. So if we have N1 and N2, then we will have the sides R1 and R2. But right now, let me continue so that you know where we have R1. So here we have R2, and this is R1. And R1 then it says, oh, okay, mobile station will traverse and something like leaving the rectangle from this side. We have the handle rate, and another one we have another handle rate. And the edge actually is horizontal, and B is vertical. But we just try to choose the two directions. Well, so we have the rate, and how to have the rate calculation. First of all, we try to have the component. Because of R1 and R2, so right now we can have A1 cosine theta here. If we have theta, and we have A1 cosine theta and L1 sine theta, and the others. So check these quickly. Right? So A1 cosine holds that direction, holds R1 side, and the same N2 cosine. Therefore, we have the rate. R1 actually we have A1 cosine and N2 sine, so this side. And we have the other side, it's A1 sine plus N2. So R1 here, because of the unit length, so we have unit length plus the length. And unit we have we have two directions, but right now we put them together. So maybe we need to have the proper. Maybe right now forget it. So here we have the handle rate, or maybe the number of mobile station will generate a handle. Alright, so we have actually we will have two directions. Maybe we go in standard layer, but right now we have the handle. It can occur at size R1 and size of R2, so put them together. So right now put them together. And put them together, right now we want to try to minimize something, the handle rate. So we try to know, okay, if we fix area here, so we have R1 and R2, so we want to have R1 and R2, and because of the relationship, we can rearrange it. If we rearrange it, so express that one in terms of, for example, R1. And then we can try to minimize these. Minimize these, how to minimize these? Express that one in terms of R1. So we can have the differentiation with respect to R1 and set it to 0. Set it to 0, then we will have the results here. If we have the results here, then finally we find minimize the handle rate, then we have this relationship. You can check it further. And actually, finally the handle rate should be this if we try to minimize. Alright, so this is a handle rate. So when we have these, and if we have the condition, then we have the minimum handle rate. So the third one actually is a problem. The problem says if we have the given description, that you have for the handle rate, and if we want to minimize the handle, how to do? It says you can try to have the expression in terms of R1. And finally, through the differentiation, we can find the condition to reach the minimized handle rate, this one. Oh, okay, if we have the proportional condition, then we can reach the minimum rate. Right, so this one actually is solves a possible problem. But I think just a problem you can have an exercise of classes. So I let it know, but I don't want to emphasize this. Okay, so I just want to make sure about the problem. Do you know the idea here? So the details later you can check all the details here, or maybe the details in the classroom. I just want to let you know we try to have the handle rate, and we want to minimize the handle rate because of minimizing the handle rate. So we need to perform differentiation, and that's it. After differentiation, we can reach the results here. Alright, so this one, you know the goal, right? If yes, then it doesn't matter that you to check further. But now let me check this. Alright, so So check these first. If you can find the whole diagram, so can you find these? Yes or no? Yes. Okay, good. Check it. Maybe the way I cannot see it, let me check. At least try to key in your answer, or maybe, okay, no, then you just key no. So finish it. Alright, then you check. Maybe I will check later. Alright, so you never finished. Maybe ask it directly. If you have the question, raise your hand. No, right? So finish it, we go to the next one. Okay. Same problem. So next one is this, attendance checking. 1 minute to finish this. Alright, so almost finished. Okay, so after now we finish some discussion, and later we will have one good discussion. And good discussion, that will have the entry on our line group, right? And later we can show them again. But before that one, in the past, actually I will have the video to check the good discussion for you to review. So here I select this one for the purpose of review for you. So look at this. So that can show me your answer. Thomas, no. Your hand. Wait. Okay. Finish. Oh, yes, yes. But you can check it later. So all I want to show, just try to make it feel, okay, if this is a presentation by you, how to adjust the way to have the presentation, including the volume. Alright, so of course you need to check how to have the adjustment, and so that it will be a far way for you to have the presentation. So as for the others, I think I skip it. If you can check some video, maybe I have some title like this, you can try to find that one. And so you can check, okay, for you, how you readjust it. And of course, maybe sometimes I use the camera to record, so it doesn't mean I will have the perfect focus. So sometimes you cannot see the content there. So about that one, I think, forgive me, I have no chance to readjust it because I need to lecture and no time to check that camera, right? Alright, so this is the checking for the video for your reference. So let me refresh it. Alright, so I think you can find the video on March 31st, and then you can find the video. And so you know, okay, this is the status of our presentation. Of course, I switched from original Skype to have the presentation to the current way. And so that we will have echo. For that one, we will have echo. And also, if we have the new system partly, it will be easier to post your answer there. And in fact, I plan to have the answer for you as well, but these 2 weeks, I think I don't have enough time, but I will find time to really have the answer. And so that you can check the problem here and what is the possible reference answers there. Even right now, you just have the answer from all students. So let us continue and move on to the third one. Actually, I already have the 3 problems, and maybe you think, okay, I can do it of classes. Yeah, sure, but I push you to do it. So I select 3 problems here and push you to focus on the 3 problems. Alright, right now maybe I don't want to assign the presenter first. I already have the exercise selected. So at least take a picture, or maybe you think, or it doesn't matter, I can refer to parallel interrupted. So right now you can check your cell phone. If you have the app, you can use the app to check your 3 problems. I post the 3 problems there. If you finish, of course you can upload your answers. I hope you have the answers simultaneously, or maybe at least you need to have the 3 separate answers. If you can have the answer put into maybe one file or one photo, you just put in one photo, and so that you just have the answer once. Or otherwise, yes, you need to answer separately to have the answer for the 3 problems. That's okay as well. So right now, then you have 10 minutes to check. Alright. Of course, you are allowed to have the way to discuss with your neighbors for sure. But the 3 problems and the due time, I set it to how about set it to noon? Is it okay? The due time set it to noon today. Now okay for you? No presentation, but need to have the answer posted on Titan. For you, maybe to 2 p.m. is okay? Only for you. It's allowed. So for me, only for me, 2 p.m. And the others, noon today. Alright, so why not? You can check it. And if you have it, sure, you can keep it. And actually, you can have any tools. But if you apply tool, you should make sure you understand why you have the answer there. Alright, so check it. So about your answer found that I expect you write your answer by hand. So I prefer the handwriting style. Handwriting style. Even if you find the solution, I expect you to write it by yourself. So handwriting will be the preferred style of the solution. And I expect you to have the solution to problems 1 to 3 simultaneously. And so that you can check it directly. it, doesn't matter. I allow you to have time to post your answer before noon. And for me, I actually allow you to have 2 p.m. to upload your answers to Padlet. So I don't know about Padlet. If you have any question about Padlet, raise your hands. If no, so I prefer you should use Padlet. It's okay. And the hyperlink you can refer to line group. Or maybe you can register for sure so that sometimes you will receive some message by email. So anyone, if ever notice email related to Padlet, or maybe no, yes or no, your email, count of email? No? Maybe for me, yes, right? So you will have the notification of Padlet. Maybe to let you know, okay, someone post the answer sale, or maybe some notification. At least you can refer to all of these and so that you can have for something else. For example, next time I have for the solution release, and then you will be notified by email possibly. Alright, that's all, so you can continue. Don't forget to have your answer before noon. Alright, if you can finish it, no problem. And for me, 2 p.m. Alright. If no further question, that's for the day and see you next week. Bye bye.